I'm Asha. I'm a PhD student from the University of Nottingham. So currently, I'm doing my PhD project on how to utilize semantic web technologies for automated construction progress monitoring. So, so I did a conference publication about some literature related to how semantic web technologies can be incorporated for construction management use cases. And that conference paper was presented in the ICCCBE conference in Montreal, Canada last year. So I was fortunate to get funding for the conference registration from ISKO UK. So thank you very much for that. So I'm going to present to you about some aspects of my research and all. And so I'll start with the data in construction, and then I'll talk in brief about semantic web, and then I'll move on to my project and yeah. So first, so in a construction project, so it's so in my project, I focus on the execution phase of a construction project. So this typically involves numerous stakeholders in a very collaborative setting. So there's like multiple streams of data coming from various arrays of digital tools and maybe software, and all of these data are in heterogeneous data formats. So there's this difficulty in integrating all this data and to come up with a meaningful output. So practically in a construction project, we are living in an ocean of data where data is dispersed across various domains. However, these are not interoperable with one another. So we have so much data, but we can't properly integrate these things together due to the interoperability issue, so that we can't get a better use of it. So therefore, so in order to overcome this issue in the construction industry, now the construction researchers are focusing on adapting semantic web technologies and linked data to overcome this trouble. So semantic web is, if we move on to the concept of semantic web, it's the concept of Web 3.0, where so it's the concept of Web 3.0, representing a web of connected data. So this extends the Web 1.0 and Web 2.0 concept into Web 3.0. And in the heart of this concept lies the concept of ontologies, which my research mainly focuses on. So if we move on to ontologies, this is a formal, explicit specification of a shared conceptualization. So it defines basic terms and relationships of a topic's domain knowledge by comprising vocabularies or taxonomies to define terms and the rules combining the terms and relations. So this helps us to build domain knowledge bases and also provide as a framework for data interoperability. At the very beginning of my research, I tried to see how semantic web, linked data, and ontologies are powerful together. Why these things are so powerful together? So at the heart of semantic web lies the idea of ontology. So the semantic web relies on ontologies and linked data to achieve its goal of having data on the web, which is defined and linked in a more discoverable way. And here, ontologies or data schemas helps to structure this data, making it machine readable, and also allow us to represent relationships between pieces of data. And also then the linked data concept, this uses the semantic web principles to interlink data from different sources on the web using vocabularies provided by the ontologies. So in summary, these three things together helps us to create interoperability, discovery, and integration, and to create richer applications. So, and also, this is what we want in the construction industry to overcome the issue of data interoperability. And this very idea of semantic web has also been addressed in the BIM maturity framework. So in construction industry, there's this BIM maturity model proposed by Bill and Richard. So, there where we talk about 4 levels, and in the level 0, it was the conventional practice back then with 2D CAD and paper-based exchange of drawings and data. And then level 1 comprised of mainly 2D and maybe partially 3D models. And here data exchange was done manually, sending and receiving individual files. And there were no central project platforms employed in here. And currently, most of the construction projects are being done in the level 2 BIM maturity level. So, in level 2, we use BIM softwares like Autodesk Revit, Autodesk Robot, and many other BIM authoring softwares to create models. However, various disciplines involved in construction projects like structural engineers, quantity surveyors, and MEP engineers, and so on, they use their own models, they use their own softwares, their preferred softwares. So, once in a while they do clash detections and all, do coordination with all these models they create. And however, data is still exchanged through in the basis of files. And however, there's this concept called CDE, Common Data Environment, where all these data are kept inside in a central platform. So this is how the construction projects are being done currently. So the level 3 BIM is what we try to achieve in the future. So in these targets on fully integrated BIM, it is based on implementation of big open BIM. So where we have vendor neutral softwares and where we incorporate data exchange schemas and all. So here we try to incorporate ISO standards and for data exchange and process descriptions, and deeply integrated models are used throughout the entire project life cycle. And here we plan to incorporate cloud services to manage project data and throughout the whole life cycle of the project. So this very idea of level 3 BIM is closely related to what we try to achieve in semantic web as well. So if we were to incorporate these concepts together, it means we can move forward with level 3 BIM. So where we can achieve interoperability, linking across different domains, and also it helps us to achieve logical inference and proof. In the construction industry, especially BIM-based BIM-based construction. So we use IFC schema to describe building-related data. For example, if we take a Revit model, so you can this data is expressed through the IFC file format. Until recently, IFC data exchange model was only available in the step file format. Now, through this organization called Building Smart, they have initiated to translate this BIM IFC step into IFC OWL, which is the ontology web ontology language representation of IFC. So this translation of IFC schema to IFC schema has made made a sort of a revolution in the construction industry, and many researchers engaged in construction industry are trying to do ontology-based research with this conversion, and also there's this community called World Wide Web. There's this community within World Wide Web consortium called Link Building Data Community Group. They focus on developing lightweight ontologies because due to the complex nature of IFC or schema to deliver various use cases in the construction industry. So some of these are like bot, product, prop ontology. So in my project, I focus on using these very concepts and to see how ontologies can be incorporated for automated construction progress monitoring. So this project is towards digital twins. So construction progress monitoring is a vital task in a project. So the scope is to develop an ontology-based framework to automate the process through fusion of heterogeneous data sources. So for that, I'm thinking of developing a modular ontology system. So the deliverables would be to create a user interface with progress monitoring KPIs and to do data integration as well. For that purpose, I have created the aim and object. I have 4 objectives in my research, because as a part of the first objective to determine gaps in knowledge, I did my conference paper, which ISKO UK funded for in registration for that conference, and currently I'm working on iterating the ontology development process, and also currently working on developing the user interface and the progress monitoring platform, and we'll eventually move on to validation part. And for the development of this framework, I focus on physical progress and to see how construction projects progress complies with the planned schedule, and to incorporate inspections and formalities to it. And I focus on near real-time progress tracking, which could be weekly progress, and so to create a collaborative platform for progress representation, and representation is the aim. And for that, I have created like a 6-layered system architecture for this progress monitoring system, comprising of data acquisition layer, where I will focus on the pre-processed data. And then there's the data integration layer, and heart of this system is the ontology layer. And there's the analytic layer, backend, and front-end layer. So all these 6 layers together will create the ontology, create this progress monitoring system that I try to develop. So the a proposed workflow can also be illustrated as like this as well. So I'll talk about this later on. So I'm following a methodology ontology development approach. So first I identified the purpose, scope, and end users of the proposed app framework, and then I move on to developing the ontology. So for this, um, I follow a modular ontology development approach, and I try to reuse existing ontologies as much as possible without creating redundancies. And so for, uh, in this proposed modular approach, I have five domain specific modules. There's onto product, focus on the structure of the construction project, building elements and all. And there's the onto process, which focus on the tasks and activities in the project. And onto resource, it focuses on resources associated with the construction project, and then schedule. And then onto data, which focus on data available within the construction project. And finally, the core module, which is the onto PMS, focusing on integrating all of these submodules and to finally create this knowledge base on ontology, on the construction progress monitoring ontology. And and these are some diagrams about the proposed on the proposed modules. So this is the product module. I have reused bot module, bot ontology with that. And there's this process module. And I always try to use upper level ontologies like BF4, ProV. And this is the resource module. And this is the schedule module. And this is the data module. And this is the progress monitoring module with limited relationship shown. So this is the final integration of all these submodules to create the progress monitoring module, which is the core. And then these are some inter-module alignments I made. And so for the validation part, I'm trying to do use a synthetic data set at the moment to see if everything works together and to iteratively develop the process. So I'm using I'm trying to use the existing IFC to RDF conversion tool to convert the BIM data, and then to do inferencing using my and to map these data with my ontology. So currently I'm working on iterating the process ontology development process, and also a validation part as well. So yeah, that's my current work, and in the future I try to validate this framework. And thank you very much for listening to my presentation. And I'm actually very new to this area, so I hope if you have any suggestions, feedback, or comments, I very much appreciate it.